The fluid section of DZynSource mold engineering software has several choices in it. You have bubbler size calculations. Bubblers are just a tube that are used to cool the inside of a core. It's just a drilled hole with a generally stainless steel or brass tube inserted in it where the water generally comes up from the inside and goes back down the outside. And all of the calculations here are based on the equivalent area method. It's the one that's typically taught. It's the way the sizes are shown in the DME catalog, and while I don't necessarily agree that it is the correct way to size holes and bubblers, that is the most widely accepted in the industry, so that's why I've included it. Also, you have a continuity equation, which is something that is kind of specific and doesn't come up a lot, but you can the relationship between area and velocity in any channel is the same. It's a ratio and proportion calculation. So if your area gets smaller, your velocity has to increase so that the two are always equal. And there are some specific applications for this. I won't get into that right now. We have equivalent hydraulic diameter. The premise of this, and this is already used quite a lot in the heating, ventilation, and air conditioning industry. They realize that a rectangular shaped duct does not have the equivalent flow capacity of a round duct with the same area because you have more perimeter, and that's what the purpose of this is. It's a simple calculation. 4 times the area divided by the perimeter tells you the equivalent diameter. And if you use a circle to describe this, it comes out as a circle, but if you use a square, the actual equivalent diameter is smaller. The circle is the most efficient because it has the least amount of perimeter to a given area. Any other shape is going to be a smaller equivalent hydraulic diameter. That's a general case. There's the specific simple case for the annular passage, and you just enter in the 2 diameters and the calculation is done for you. You have some conversions that are based on gallons per minute and liters per minute, and it just changes them to velocity. You have some hydraulic cylinder calculations which are quite handy. I will go through that a little bit later. I'm just showing an overview right now. You have pneumatic cylinders as well. There's a cylinder sizer here, and also standard cubic feet per minute of air required is included in this section, calculation. Pressure losses using Darcy's equation, and also pressure loss through an orifice with 2 different types of orifice plate, and Reynolds number, which is something that is quite important in mold design and mold manufacturing and molding. I will go through each of these one at a time in separate videos.